lesson 4, algebraic expression applications. So our goal today is to evaluate expressions, algebraic expressions for application problems. So just a little reminder, the numbers in front of your terms, these are called coefficients, okay? And then the letters are called your variables, and together a coefficient and variable make up a term. So right here, negative 2x plus 7y, that's two terms. And we have two coefficients and two variables. Okay. Some tips for writing expressions. We need to identify the variable and think about what changes. So what's our variable? What's changing? And then our relation to how the variable is changing. So we have to look for the word per. The word per usually means multiplication. So think of like per hour, that's multiplying by the number of hours. So we'll see when we get to these examples. So we're going to write an expression for each scenario, then use your expression to evaluate for a given value. So first we need to identify the variable. So in scenario number 1, your part-time job pays $10.25 per hour. So there's that per. What will your paycheck be if you work 36 hours per pay period? So think about what's changing. Well, what's changing is the number of hours you work. So our variable is hours. So we can use the letter H for hours. That's what's changing. Our expression, well, it's $10.25 per hour. So we know that our coefficient is going to be $10.25, and then it's every hour, so that's actually multiplying. So we're going to do $10.25H. When you have your coefficient next to a variable like this, it means multiply. So $10.25H is our expression. Now we need to evaluate our expression. So evaluating our expression means we're going to be plugging in a value. So we worked 36 hours in this pay period, so we're going to plug in 36 for our H. So we know that it's 10.25 times 36. Let me just grab a calculator. So 10.25 times 36, we get our answer of $369. Okay, I'm going to put my dollar symbol because we know it's, we're working with money. Okay, so that's our answer. A dozen eggs cost $1.18, so that's number 2. A dozen eggs cost $1.18. What is your bill before taxes if you get 3 dozen? So we need to identify our variable. So what's changing? Well, the amount of eggs you're buying at the store is changing, so we can use E for dozen eggs. So the amount of cartons of eggs you're buying is what's changing. So it's $1.18 for every thing of eggs. So think of that kind of like it's $1.18 per egg carton. So it's 118 E is our expression. Now we're going to evaluate. So we bought 3 dozen eggs. So we're going to plug in 3 for our E. So it's $1.18 times 3. So 118 times 3, we get $3.54 for our answer. That's how much you're spending at the store. Okay, flip the page. We have one more problem left. Scenario number 3. So you want to create a rectangular garden plot where the length is 3 feet longer than the width. What is the expression for the area of your garden plot? What will the area be if the width is 9 feet? So we need to identify a variable. So let's think, what is our formula for area? So we know that area is equal to length times width. And then in our problem, we know that the length is 3 feet longer than the width. So we don't know anything about width. So in this problem, our variable is width. That's what's changing. Okay, our expression. So we know that's length times width. Well, what's length? Well, length is 3 feet longer than the width. So we know that the length is actually 3 plus w. So in our expression, we have 3 plus w times our width, which is just w. That's our expression. Now we need to evaluate the expression. Well, in our problem, we know that the width is 9 feet. So now we're going to plug in 9 feet. So 3 plus 9 times 9. 9. So 3 plus 9 is 12. 12 times 9 is 108. So 108, and then don't forget our unit. Area is feet squared. Okay, and that is the end of expressions. I know this unit is a little bit harder, so if you have any questions, please reach out.